Okay, now we move on to the second part of the phase shift oscillator. It is still the oscillator circuit, but we look into another type of oscillator with the same topic learning outcome, where you should be able to describe the operation of phase shift oscillator, analyze it and derive the transfer function, draw the waveform related to it, determine the frequency of oscillation, and how to design the phase shift oscillator. Okay, initially we have talked about this type of phase shift oscillator. Now we move to a similar circuit, but we swap the position of R and C. If you look over here, the C is up there, but this one, it is R, the resistor. So it will give a different frequency of oscillation. Okay, so for this type of phase shift oscillator, we still have the amplifier, which is an inverting amplifier with 180-degree phase shift. Okay, so your input VI over here will be out of phase with the output. Your VI is actually the feedback voltage over here, and this part is your feedback network or the feedback factor. With a positive feedback, it will introduce another 180 phase shift. You have 3 pairs of RC. This part will select the frequency of oscillation, and it is also an attenuator. Your output signal will be fed to this feedback network, and the signal will be lowered, okay, in terms of the amplitude, and it will be amplified again. So there is a closed loop, and this must fulfill the Barkhausen criteria of 360-degree phase shift around the loop, and beta, this is your beta, multiply with the gain must equals to 1. So this is what we'll analyze. Okay, and we just look at the feedback network. Okay, I define a current I over here. Actually, it is the current flowing into the amplifier. This current is assumed to be very small. We can ignore this current because the value of your RA over here must be much larger, 10 times compared to the impedance of this capacitor. With that, we can ignore the current. So we simply have the current I5 over here flowing and I6 flowing through the capacitor. So with that, at this particular node, can say that I5 equals to I6. Okay, now we define the voltage over here Vy and not Y. The current just now is I5 and I6. Applying the Kirchhoff current law, I5 equals to I6. Since I5 is flowing from Vy to Vf, so I can write I5 to be Vy minus Vf divided by the resistance over here R, and it is equals to I6, which is the current flowing through the capacitor over here, which is Vf divided by the impedance of the capacitor over here. Actually, Vf minus 0, so I just ignore 0. Vf divided by 1 over j omega c. Simplify the equation, bring over j omega c on top of the equation, cross multiply with the r. So you have Vy minus Vy equals to j omega rc Vf. Simplified, you have Vy equals to 1 plus j omega rc Vf. And with that, we finish with the phase shift oscillator.